Now let's see this question. Which of the following is not a distributive lattice? So the question is about distributive lattice, and we already know that if you have to test whether a lattice is distributed or not, you have to test whether that particular structure L1 star and L2 star are not a sublattices of the given lattice. Okay. Using that rule we can continue. I hope you remember that L1 star and L2 star, right? Okay, first one is power set of A, and the relation is a set inclusion on a set A containing A, B, C, D, 4 elements. So that is the first one. Now if you observe this one, power set of A, which is nothing but set of all subsets, and if you observe this set inclusion relation, you can find something here. Always we know that the join of two elements is nothing but the union, right? And the meet of two elements is nothing but intersection. And we know that on a set of all sets, union is distributive over intersection and intersection is distributive over union. So we already know that these properties are holding right or holding good on set of all sets, isn't it? Therefore, since this distributive property is always holding good on set of any sets, we can directly say that in this case it is distributive. So I'm not going to take the entire poset and examine it. Instead of that, I'm just relying on the fact that for any set of sets, intersection is distributive over union and union is distributive over intersection. Using that rule, I'm just solving it. So since intersection is distributive over union and union is distributive over intersection, it is distributive. So distributive law holds good on this particular poset, which is set of all sets, in this case set of all subsets. Therefore it is distributive. First one is distributive. Now let's talk about D81 and divides. So what is D81? D81 is set of all divisors, positive divisors of 81. What are all the positive divisors of 81? 1, 3, 9, 27, 81. So these are all the elements which divide 81, right? And now the relation is divides. Okay. So it is one important property that you should remember is for any dn where n is a positive integer, always dn comma divides is a distributive lattice. Okay, always dn for any integer, always dn comma divides is distributive. Okay, and now if you observe this one, this particular poset, so we know that 1 divides 3, 3 divides 9, 9 divides 27, 27 divides 81. So it is a total order, and we know that every total order is a distributive, right? Distributive lattice. Therefore this is a distributive lattice because it is total. But in general, whenever you see dn and the relation divides, remember that it is always distributive. Okay. And the next one is set of all real numbers and less than or equal to. Where R is set of all real numbers. It is also a total order, isn't it? So it is a total order which will contain all the numbers, real numbers. It is unbounded, but still it is a total order, and we know that every total order is distributive. Therefore it is also distributive, right? So why is the total order distributive? Because it is containing a chain, and chain will never contain any sublattice which is isomorphic to L1 star or L2 star. Only when we contain L1 star and L2 star, then only a lattice is not going to be distributive. That is why. And if you look at this one, the last one, D, some numbers are given 1, 2, 3, 5, 30 and divides. Now if you try to put them in form of a lattice diagram, 1, 2, 3, 5 and 30, right? So this is isomorphic to L1 star. Therefore it is not distributive. The reason is the element 2 is having two inverses, two complements, 3 and 5. Similarly, 3 is having two complements, 5 is having two complements. Since they are having more than one complement, you can just directly declare that it is not going to be distributive. Got it? Or even this is isomorphic to the Selvan star structure. So you can go even that method. Therefore, it is not distributive.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.